Hi guys! Welcome to our log and exponential parent functions. Now, we've already done exponential parent functions in this class, but I'm going to compare them with logs today as we learn the logs. We're going to need Desmos, and so I've already got me a Desmos screen pulled up. So let's go and practice this. The first thing it says is we want log base 2 of x. So I'm going to go over and see Desmos. Okay, so you should be able to see Desmos on my screen now. And I want to be able to put that little log base 2. It's not easy to do that with the functions they have here on the calculator. So I'm just going to move this little guy over some and show you what we have down here. See, it's not really easy to find subscripts and stuff. So I'm going to teach you something else. Anytime you have a log with a little base on it, then one of the things that you can do, so what I'm going to do here, is I'm going to do log of x divided by log of the base. Base was 2. This means the same thing as log base 2 of x. Now you can see there's me a graph over there, and what I'm going to do is I'm going to get a table, and you can see on ours we want 0, 1, 2, 4, and 8. So I want 0, 1, 2, 4, and 8. So my answers I'm going to put in my table on my worksheet are for the undefined 0, 1, 2, and 3. So I'm going to go back to my worksheet. And now I'm going to type in my table. This one I'm going to put undefined, because that's what the table said. Then at 1 it said 0. Then the next one it said 1. Then it said 2. And then it said 3. All I did was copy the table. Now I'm going to try to draw in this thing. And like I told you, you guys aren't going to be experts either at drawing. I'm not expecting that. So I'm going to put me a few points on here. It looks like I've got, at 0 it's undefined. That's probably going to be an asymptote. At 1 it's at 0. So I'm going to have me a little dot here. At 2 we're at 1. And at 4 we're up at 2. And at 8, 6, 7, 8 we're up at 3. Now I'm going to try to draw in there with those. See, again, I'm not any better artist than you guys are. And then I'm going to make this long tail down here that we saw in Desmos. That's not a very good arrow at the end, but you get the idea. So there he is. Now, what was going on here at 0? Why is it undefined? That's because there is actually a nice dashed VA right here at 0. See, I can't even draw a vertical asymptote. It's a dashed line that goes up and down. So it'll never cross this axis. All right, so there's our curve. He's kind of this J that's been moved around. Now 2 to the x, you should know what he looks like. But if not, we can go back to Desmos and type him in. So I'm going to put 2 to the x. Okay, and you should have 2 to the x on there now. I'm going to go ahead and use the J-shaped curve. Get his points. There they are. I'm going to go fill them in on the worksheet. So back to the worksheet. At -2, you guys had 0.25 in Desmos. At -1, it was 0.5. At 0, it was 1, 2, and then 4, and then 8. These are what you have. And now we're going to plot those dots. So at -2, it's about a quarter. -1, it's about a half. 0, 1. 1, it's at 2, 2, it's at 4, and 3, it's at 8. And then connecting those dots. There we go. Make our J-shaped curve. And if you remember from last week, we talked about the reason why he doesn't go underneath is there's an HA that is hanging out here. It's the dashed line that I'm trying to draw. Now this one says log x. So I'm going to go back to my friend Desmos. I'm going to type in log x. And he didn't have a base down there on there, so I can just type him in. Wow, he looks just like the other guy a moment ago, just maybe not as steep. So log x, let's go get his points. Now, according to my worksheet, all I wanted was the values at 0, 1, and 10. So I'm just going to type over this. At 0, it's undefined. 1, so undefined, 0, 1. That's what I need. So I'm going to go back to my worksheet. I'm going to fill in my table. Undefined. And then 0. And then 1. I got these numbers from Desmos. Hopefully it didn't lie to me. And then I'm going to graph them. So at 1, it's at 0. And at 10, it's at 1. Try to get it up there. And then I'm going to draw my little curve in there. So between here and here. Yeah, I'm not an artist. And down here. And then remember, all the way down here on the y-axis is my dashed VA. That's why it's undefined at 0, because there's a VA there. Look how much he looks like that guy, just not as tall as that guy. So he's a little closer to the x-axis than the other guy. 10 to the x, you all did this one last week. So I'm going to go ahead and get the numbers for 10 to the x. So go back to Desmos. Okay, so 10 to the x. Go get his numbers in the table. There we go. There's our numbers. Now I'm going to go back to, remember he's a J-shaped graph, just like we expect for an exponential. Let's go back to our worksheet, and we're going to type these in. So this one's 0.01. I got these numbers from Desmos. 0.1. 10 to the 0 is 1. This one's 10. 100. And this guy, 1,000. All right, now I'm going to try to graph him. At -2, he's barely there. Same thing at -1. At 0, 1. At 1, he's all the way up at 10. And I'm trying to draw this graph. He's a really steep J. And remember, he has a HA right here on the x-axis. That's why he never goes below it. Oh, LN. This one's kind of weird. LN stands for natural log. And he's a log with a base of E. So if I have to put him in Desmos, which I'm going to, I will show you how to do that. All right. So LN. It's a log of a base of E. You can actually type in LN of X. Ooh, isn't he pretty? He looks just like all the others. He's just a little taller than the log one, but not as, well, I think he's a little taller than also the log 2. Now let's get some points for him. All right, so what points do we need? According to this, we want 0, 1, 7, and 10. So I'm going to type that on here so I don't forget it. 0, 1, 7, and 10. Those are the numbers I want. So undefined 0. So I'm going to go back to my worksheet. Text box. Undefined. This one's going to be 0. Here's the decimals. So go back to decimals and get these two decimals. 2.30. 1.95 and 2.30. 1.95 and 2.30. Where did I get them? I went to Desmos that we had done a moment ago and just looked at the table. I just didn't want to flick back and forth so much for you. All right, now I'm going to plot them. At 1, we're at 0. At 7, we're almost at 2. And at 10, we're about 2 1/3. So draw that in. Again, not the best artist, guys. Yeah, he shouldn't be bumpy in there. He should be a nice smooth curve with a long tail. And he should have, right here, a nice VA. Now, e to the x, we did that one last week. So we can go back to Desmos and type him in. Which is literally e to the x. Remember that was the Euler number. It's going to be a bunch of decimals. According to this, we want -2 all the way up to 3. So I'm going to add one more here for 3. So I want 0.14, 0.37, and then 1. So back to the screen. A text box. 0.14, 0.37, and 1. I got all those from Desmos. This one's 2.72. All right, let's go back and steal the last two. 7.39 and 20.09. 7.39 and 20.09. I'm just going to check those. Okay. All right, so now we've got them. We're going to plot them, and we should have the J-shaped graph that we had last week. We did this guy. 0, 1, 1, he's at 2.7, at 2, he's at 7 1/3, and at 3, he's way up at 20. So we're going to make this J go through his points as best as we can. It's not too bad of a J, is it? And then remember, he has his HA here down on the x-axis. All right, let's look at our graphs. The logs, any of them that have the word log, LN, something like that, they're shaped like this. Long tail, and this little like curve up here. Any of them that are exponentials are the J shapes. So there's the word log again, exponential. The word log and exponential. Now, hopefully we're noticing some other things about them, but logs are all the same basic shape. So we're going to find all the key attributes of a log together real quick. So I'm going to circle some things on here that we all can see. Now remember, with domain, that's left to right, the x's. So over here on the left, there's an asymptote on every single one of these at 0. And then on the right, there's an arrow. So we're going to be going on all the logs from 0 to infinity. So I'm going to go down here to question 7, and it talks about logs. What is the domain? Well, all of them are from 0, where the asymptote is. Sorry, guys, I forgot to hit the equation thing. 0 to infinity. So that's where the arrow is. That's every single one of these logs domain. Now I'm going to go back to the logs and look at their range. Go back to the logs. I'm just going to go to the first one because he's easier to see. Now range means we're going bottom to top. So down here at the bottom is an arrow. And at the top is an arrow. So the range is negative to positive infinity. So we go back to number 7. Every one of these guys has the same range. Negative infinity. I don't know why I made that yellow. You cannot read that. So, negative infinity, comma, infinity. And let's see if we can put him back up where you can see him a little better in the box. Now we need to find the x and y intercepts. So I'm going to go back up to a log. All right, x and y intercepts. Now we know a little bit about x and y intercepts because x-intercepts would be on the x-axis. That's right there at 1. Y-intercepts, oh, there's an asymptote there, so no y-intercept for any of the logs. Look at these logs. See, there's the same x-intercept. And there's another log, same x-intercept. So all the x-intercepts for the logs are at 1. There is no y-intercept for any of the logs. Why? Because on the y-axis, there's a big, giant, honking asymptote. And that asymptote is the VA. So that's at x equals 0. That's the y-axis. And there isn't an HA on logarithms. There's not a flat one. So there is none. Now, you're going to have to review your exponential functions and their domain range, all their key attributes. So let's just go to a basic exponential. There's one right here. Just going to look at him. Now we're going to go take him apart real quick. Domain. Domain goes left to right. Arrow to arrow. So his domain is negative to positive infinity. So that's exponentials. It's negative infinity, comma, positive infinity. That's his domain. Every J-shaped graph has the same domain. Now, we're going to go back to number 6 up here and look at his range, bottom to top. Bottom is an asymptote at 0 to infinity. The range is 0 to infinity. So I'm going to go ahead and type him in here. 0 to infinity. There he goes. All right, I got him in there. Now we got to look at x and y intercepts. So I'm going to go back up to my J-shaped graph. There are no x-intercepts because that's where the V or the HA is, but there is a y-intercept at 1. And that's true of every one of these J's. Look, there's the y-intercept at 1. So I'm going to go over here and I'm going to type in that there is no x-intercept because that's where the HA is, and the y-intercept is at 1. And there is an HA. He's at y equals 0. He's on the x-axis. But there's not one that goes up and down. No VA. So none. Now you look really carefully at all of these things. I'm going to tell you, look at this table. And I'm going to say, I'm going to give you some hints when you look at this table. So let's see here. I want to go and get some bright colored red because I want you to really, really, really see this. Marker red. All right, there it is. Look at this guy's domain and that guy's range. And then look at his range compared to his domain. And then look at this one's x-intercept and his y-intercept and vice versa. And then look at these vertical and horizontal asymptotes. Now, I'm going to tell you that logs and exponentials are inverses. Inverses mean you switch x and y. Switch x and y. Hopefully you're noticing a pattern here. If not, maybe one of the other things you're noticing is that if I was to say, here's a nice, beautiful exponential. If I add the log in here, now remember, I'm not an artist. I'm going to put my friend that looks like a log graph. Remember, he has the long tail here. Oh, isn't he beautiful? And I am going to try to draw in between them this one here. This is the line y equals x. Now remember, it should be a straight line, but I can't draw with Kimmy. Look at that. Are they not the same on both sides? Mirror reflections on both sides of that y equals x. If you look at that, they're the same on both sides. So that makes them inverses over the line y equals x. That means you can switch their x's and y's. That means their domains and ranges, their x and y intercepts. That's why this table looks like it does, because the domain and range can swap x and y. The x and y intercept can swap x and y. The HA and VA can swap x and y because they're inverses. So I want you to kind of, in number 8, put in words down here what you're seeing between the tables, the graphs, the equations, the key attributes, anything that you're seeing. Maybe you notice that VAs go one way and HAs go the other, and one of them has a VA and one of them has an HA. Maybe you're noticing these things. So I just want to make sure that you write down something that you're seeing that's the same or different in these on number 8. And then you turn this in after you filled in everything that we worked out together. And then you turn it in. Okay? Well, have a good rest of your graphing. Bye, guys.